So hello guys, physics 102 electricity. Let's quickly talk about the introduction to electricity. Now the introduction is that we cannot have electricity without charges. So for us to have electricity, charges must be present. Charges must be present. Are we together? But it can be present in two forms. But note the fact that there is a presence of charge or there are presence of charges, there must be electricity. But it can be present in two forms, whether in static form, that is when it's not moving, or in current form, that is when it's in motion or when it is moving. So when charges is present first, then if the present is in static position, then the kind of electricity we have is what we know as static electricity. And we study that static electricity under electrostatic. If charges is present as in form of current, that is if it's moving, then we have what we call current electricity. And we study this under electrodynamics. In short, for us to have electricity, we must have charge. There must be presence of charge. So, but what kind of electricity do we have due to the state of charge? If the charge is in a single position, that is if it's at rest, if it's not moving, if it's static, the kind of electricity we have is static electricity, and we study it under electrostatic. If the charge is not at rest, if the charge is current, that is if the charge is in motion, then we have current electricity, and we study that under electrodynamics. So that's that for that. But note, present gives electricity, presence of charge. So it's not about maybe it has to move or not. The fact that it's present, you have electricity. But if it's not moving, you have static electricity. If it's moving, you have current electricity. Take note of that. Now we have two types of charge. We have the positive charge, and we have the negative charge. These are the only two types of charge we have. There is no other, just these two, the positive and the negative. Are we together? And we have one proton to be equals to plus 1 plus E, and we have one electron to be equals to negative E. This is plus 1.6 times 10 raised power minus 19 C. This is minus 1.6 times 10 raised power minus 19 C. The positive charge, the negative charge. This is their comparison to proton, the relative charge of electron to proton and that of proton to itself. So these are the values. Note, the is positive. The ordinary 1.6 is something else. This vector, take note of that. There must be positive or there must be negative. If they ask of the magnitude alone, then you can claim. But if they don't ask magnitude, this plus is not same thing as ordinary 1.6 times 10 raised by minus 19. So there is something we also call law of conservation of charges. It states that charges can neither be created nor destroyed, but it can be transferred from one body to another. You can't create charge, you can't destroy charge. Then since you can't create and destroy, then how do we now have all these ions? We have that by disturbing the stability of an atom. Normally, all atoms are neutral. Normally, before we disturb their stability, all atoms are considered to be stable. We know they are neutral atom. Do we on a normal sense, on a neutral sense? So because here we have atom. This is an atom. We have the nucleus. As inside the atom, but outside the nucleus, we have the electron orbiting the nucleus, which they are the negative charge. And inside the nucleus, we have the proton and the neutron. This proton is the positive charge. This neutron is zero charge. Does not have charge. So when we are in this course, when we are talking of electricity, neutron has no contribution. That's why till the end we won't talk about neutron. The fact that we are mentioning neutron is just to tell us that it does not have charge. But in terms of electricity, there's nothing to do with neutron, because for us to have electricity, charges must be present. And since neutron is chargeless, then we don't need it in case of electricity. So the contribution to electricity is either proton. For proton and neutron, they are the ones that contribute to electricity. Are we together? So since This is positive, this is negative, and they have the same magnitude, so they cancel out. So normally an atom is considered to be neutral. But whenever we disturb the stability of an atom, that's when you can see that there is a maybe a disturbance in the electron in terms of loss, a disturbance in the electron in terms of gain. Note, till we end this course, electricity and even magnetism itself, proton is not disturbed. We can only disturb proton under radioactivity, but in electricity it is only neutron, because there's a strong nuclear force that bind the proton like that. How can I put it now? Let us say strong nuclear force that join the proton together in the nucleus, so it's not easily disturbed. And even without that, the electron is outside the nucleus, so it's very easy for us to disturb the electron before we can get to the proton. But either of the way, whether you don't even understand what I'm saying, but just know throughout this course we don't touch proton. Proton remain intact, nothing happens to it at all. But for electron, it can be disturbed, whether by loss or by gain. And those loss and gain is very, 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 very extremely small compared to the total charge of a whole atom. I'm trying to remember the infinite small value of one electron loss or one electron gain compared to the total charge. I think it's kind of times 10 raised power minus 30 something, if I'm not mistaken, but I'm not sure about that. But just know that whether it's plus 2 electron or plus 3 or minus 3, that is gain or loss, is very small compared to the total charge of an atom. Is that clear? So when we disturb the stability of an atom, we have a deficit or we have an addition. Do we get? So that's one thing you also need to know. So I'm trying to check something. Okay, that's that. Electron and proton, they make the atom to be neutral because they have equal in magnitude and they are opposite in sign. But when we disturb their stability, we either lose electron or we gain electron. We don't lose or gain proton under electricity and magnetism. That's that for that. So also, charges can exist without mass. It cannot exist rather. Charges can never exist without a body, without mass. But a body can exist without charge. Take note of that. So before we move on, I don't know if I've skipped anything. Let's quickly move to elementary particles. Elementary particles, we have 17. This 17 is grouped into 2, which are what? Fermion and what? Bosons. So this fermion is grouped into 2, is 12. Fermion is 12. So we have leptons. Leptons, we also have what? Quarks. Boson, we have 5. So this one is 6. This one is also 6. So 6 plus 5, we have the 17. 17 is grouped into 2, fermions and bosons. Fermions and bosons. 12 fermions, 5 bosons. Under the fermion, we have 6 leptons and 6 quarks. For the quarks, we have the UCT. Let me just give you the code. And we have the what? The BDS. So the UCT stands for up quark, charm, CH. This charm. Up, UP, up quark, charm quark, and top, TOP, top. So UCT, we have the up quark, the charm quark, and the top quark. For the BDS, we have the bottom, we have the down, and we have the strange. I think there is one that they have nickname. I think one is called Beauty. Yeah, I think, is it the bottom or the top? They have a nickname. I think this top is also called Beauty, something like that. I'm going to confirm that and drop in the comment section. But the main name is bottom, down, and strange, up, sham, and top. Up, sham, and top, bottom, down, and strange. So all the UCT, their charges is plus 2 over 3e. All the BDS, their charges is minus 1 over 3e. So how do we now know that proton is indeed, how can we confirm that proton is indeed plus 1 charge, that proton is plus 1 charge? Now proton when Dalton was saying atom is indivisible, no, scientists later discovered that we can have proton, neutron, and electron in the atom that is divisible. But furthermore, proton is not just proton, it's also subdivided into three major quarks: the up and another up and a down quark. So we have UUD quark inside a proton. So now let's calculate the charge of a proton. Since U is plus 2 over 3 plus another 2 over 3, D is under BDS, minus 1 over 3. The SCM is 3. This is 2 plus 2 minus 1, right? This is 4 minus 1, which is 3 over 3. And that's plus 1. So it's complete. Proton is plus 1. Now for neutron, neutron is zero charge, right? So neutron contain 3 quark as well, but 1 up quark and 2 down quark. 1 up quark and 2 down quark. So an up quark is plus 2 over 3. Down quark, it belongs to here, minus 1 over 3 minus another down quark, 1 over 3. The SCM is 3. This is 2 minus 1, which is what? Is 0 over what? 3. And that's 0. So they can give you that a particle contain maybe 3 up quark, 4 strange quark, 7 charm quark, 18 top quark. What is the total charge of the particle? So you know that all up, charm, and top are plus 2 over 3, and BDS are minus 1 over 3. B, bottom is minus 1 over 3, D is minus 1 over 3, S is minus 1 over 3. So just know that all BDS, like Bachelor of Data Surgery, can just use that code. UCT 2 over 3, BDS 1 over 3. So this is how to just calculate the charge of a particular particle. Now we are done with quarks, the 6 quark under fermion. Now let's move to leptons. For leptons, we have one, which is the symbol is like mu. So the charge of one is minus 1. Let's say minus E. We have tau. This is the symbol like torque in form of T. So the charge is also minus E. We have the electron, symbol of E. The charge is also minus E, or minus 1 charge. Are we together? Since E is minus 1, so this is minus E. So we also have the muon neutrino, which is V mu. Charge is 0. We have the tau neutrino, which is V then and tau. The neutrino there is V. Charge is 0. We also have the electron neutrino. This one is also VE with a charge of 0. So how can you remember this thing? Just know that all the muon, tau, and electron, they have a charge of negative E, negative 1 charge. Do we get? So this, just add neutrino to everything. Muon and its neutrino, tau and its neutrino, electron and its neutrino. All the neutrino, they have 0 charges, 0, 0, 0. All the muon, tau, and electron. This is not geo, like torque. So they have minus E. So these are the 6 leptons. We have discussed the 6 quarks. So 6 leptons and 6 quark, they are 12. That's 12 fermions. Now for the bosons, no, we have 17. We've discussed 12. The boson, we have the Ig bosons. Ig, we have the gluon, we have the photon, we have the Z bosons, and we have the W bosons. This W boson is in 2. We have the W plus and the W minus. I think this Z is 0. Yeah, if I'm not mistaken. Now, all bosons, they are force carriers. Please take note of that. They are force carrier. They carry forces. Do we get? So this gluon carries strong nuclear force. We call it SNF. Strong nuclear force. Photon carries electromagnetic force. EMF. Photon carries electromagnetic force. Z, this one carries weak force, carrier of weak forces. W boson is also what? Carrier of weak forces. While Ig boson, this Ig now is the one that is responsible for particle mass. This one is responsible for the mass of particle. So those are the 5 bosons responsible for mass of particle: gluon, strong nuclear force, photon, electromagnetic force, EMF, Z bosons, carriers of weak force, W boson, carriers of weak force. So we have many other things to say, but this is just, let's start with this. So see you in the next video. Don't forget to like and subscribe. Thanks you.